I think yes, we should be live right now. And the music tells that we may start, I think. Go.
Good morning, everyone. Welcome to see you on our new game testing event. Today, together with Pavel Krasnou, lead game tester, we are going to talk about performance testing. One very hot, I can say, topic for a lot of gamers who struggle to play their game or struggle to test the game they want to play. And I'm Nikita, still mobile tester, still not a game tester. And together with Pavel, we're gonna discover this topic. How are you, Pavel, today?
I'm fine, thanks, and yeah, hi everyone. As you see my screen, we have lots of strange numbers and some statistics and some data is going on. So yeah, today we will dive a little bit deeper into performance and performance testing, of course. But if you are a PC player, it's always not a problem, but a situation where you need to solve what you want to see: better graphics or more smooth gameplay, like 60 FPS, 120 FPS, and nowadays we see that high frequency monitors are very popular for cybersport. They have even 500 Hz, and you need a really powerful PC to really calculate, compute these frames. Also today we will talk about these modern technologies that are on hype in video games for like last, I don't know, maybe 6 years. I'm talking about RTX technology that NVIDIA invented, ray tracing, path tracing, DLSS, frame generation. We'll try to demonstrate how it works because nowadays we have, if I'm not mistaken, on last conference NVIDIA told about six times more frames using this technology. So you think one frame is calculated by GPU, and other thing, 6 is drawn by AI, by neural networks. Does it really works like this, or it's it's like a cores in CPU. If you have 2 cores, it doesn't mean that you have 2 more power. No, they have some kind of queue, and you have maybe 1.5, 1.7 more performance. Okay.
It's great. The first question, the first topic I would like to cover, but what is performance testing in video games? I'm asking because, even as a mobile tester, when I talk to guys, we have misunderstanding sometimes because maybe sometimes testers, developers, when they're talking about performance testing, they talking about like API testing for the response time, for the load testing questions. For example, in mobile testing, in most of the cases, we are talking about how fast the screen can be opened, some things like render time. And as I understand, you can elaborate on this question a little bit more. When we are talking about performance testing in video games, it's not the same topic. Yeah, it's something different.
Yeah, absolutely. If we are talking about applications, usually we talk about how fast it opens, how fast your requests are going to server, how fast response is received, and how your like a client open this response. So yeah, in video games, the main characteristic is frames per second, like how much frames your GPU computes in 1 second. As you see right now, I have nearly 50 FPS, and I can't say if it's okay, if it's great or not, because we need to have requirements. If you're talking about testing, for everything we need requirements. And nowadays games are the same game is developed for different consoles. Xbox, previous generation of Xbox, PlayStation 4, PlayStation 5, even we have Xbox Series S. So we have the most powerful configurations, and at the same time this game should work on less powerful things. So we need requirements. And usually a good tone is to have 60 FPS, smooth gameplay on 60 FPS. But 60 FPS are not enough because, as you see, let me go to the menu. Under my frames per second counter, we see some kind of graphics and milliseconds. It tells you how much time does it takes for GPU to calculate each frame. So when we have 200 frames, each frame takes nearly 5 to 6 milliseconds. But when you have 60 FPS, it goes up for 17 milliseconds, for example. So this thing is called frame time. So how much time each frame is calculated. So the best scenario is when we have 60 FPS and this graph is like line. No any peaks, no any changes, like each frame generates for exact milliseconds. Milliseconds, just imagine what's going on this processor. In this case, you have a list of hardware and requirements like this resolution, this frame rate, and this frame time. But it doesn't work like this. We also have CPU that needs to take these frames from GPU, so it helps. So not only GPU is responsible for calculating frames. CPU also super important, because if you have slow CPU, we won't see all the frames that GPU can generate, but no, CPU can't provide these frames to your screen. Also, RAM is important. So if you don't have enough, I'm talking more about video RAM, so memory that has video card, because where these frames are located? In memory. Oh, I love these guys. Their shields are exploding, and we have great. Our performance drops to 30 FPS because you see how much thin particles appear on the screen.
These guys solo now FPS, right?
Yeah. So.
And you touched this topic about requirements, right? So how we can understand what requirements will be. I know that maybe it's not the usual question to a tester. Maybe sometimes you just have already written requirements. But if we go a little bit beyond and trying to understand how it works in general, so when this where this requirement comes from.
Where this requirement comes from? Okay, at first you need to understand on what platform your game will be released. It may be only PC, and it's fine. But nowadays you need to sell your game. We discussed this in previous streams. You need to sell your game to much more audience as possible. In this case, you need to understand on what platforms they will be playing. So if we return to our Steam survey, we will see that still RTX 360, that more than, 6 years ago was demonstrated. Most of them has just 8 gigabytes of video RAM, so it's pretty old graphic card, and but it's very popular. It's enough for all modern games that are in release today. So you need to understand what you want to sell to more people, or you want to create some kind of benchmark that will use everything that nowadays graphic cards have, like double RTX 5090 to show, super realistic path tracing light. And talking about path tracing, how it works. You see this red columns, something like this. And we can see that how path tracing and ray tracing works. I will later a little bit describe what the difference. You see this red light when I go near or further, so it appears on the shield, on a gun, and when I change my point of view, it really reflects in a way like it would be in real life. That is super important, because this technology it works like this. From your point of view, from your virtual eyes, game sends a lot of arrays, real arrays, to see how the light is reflected. So they reflect not only from one surface, they go to the wall, then to the gun, then to the shield maybe. So it requires enormous power to calculate all these rays. I want to demonstrate you like this because in real life we understand that light from lamps, from the sun, they are like unlimited rays. We can't count them, so we just see the light. You can't say how much rays are there. But graphic cards have limits, and you see that real-time denoiser right now is enabled. It shows us a pretty good picture. But if I will disable this denoiser, you will see a sharpness. You will see that you may think that it's a bug that the game is breaking. Yeah, you see dots, lots of dots, like of sharpness, like lots of noise, and these dots are rays, exact rays that are calculated in real time by graphic cards. And yeah, we see so game calculates everything, so like floor, walls, ceiling, and even the things that are very far from a player. And yeah, it's we can play like this. It's not great. That's why we have technology like denoiser and DLSS also, because if you may see that DLSS is also enabled in my configuration, not in best quality but balanced, because if I turn it on to DLA or disable, we will see like 15 FPS maybe. So if you will calculate all these rays in real time for all the pixels for real resolution, like now I have 2K, like 1440 p, and when the DLSS is enabled, game calculates all these rays and all the graphics for resolution. It depends, but much lower. I don't know if statistics from this game shows us. So we see here that the current resolution, but we don't see that how much does DLSS lowers the resolution. In what resolution everything is calculated. Right now it's calculated maybe in 720p, like 4 times smaller image than later using DLSS, using neural networks, using AI. It's like stretched, but not stretched. It's stretched in very smart way to imitate that you play in 2K, in real 2K. But it's calculated in HD. I wish I described this correctly.
Yeah, that's great. Basically, this setting is very spectacular. Yeah, we can see how it works for that technology. That's great. And the question that come to my mind, for example, if I raise an issue ticket, a bug, if it will be enough just to describe, oh, I have a significant drop of frames per second in this location or in this scene, or I should dive a little bit deeper and say, oh, that's because we have too many ray tracing in this scene, for example, or something like that. How do you think?
As I mentioned before, it would be great to have the same performance in any scene in video game. Yeah, some things like this, it's not too powerful or too hard. We have nothing here. No enemies, no flying particles, objects, some kind of... so nothing here. But even in this time, if I disable DLSS, so real 2K are calculated right now, we have 24 FPS and nearly 50 milliseconds for each frame, and vertical synchronization is disabled, so sometimes we see that our frame are some kind of tiered, so it's not smooth. You can't play like this. You can, 25 years ago we played in much worse performance than this. So, your question, should you report a bug if you see in something drop of performance? I think yes, because on my previous projects, how we tested performance. developers gave us a build of a game or of a level. It's not super important, and they implemented into this game some statistics gathering, some kind of data miners or something like this. So you launch a level, you enter some command in command line. If someone didn't see command line previously, usually it's looks like this. So you in this engine, I don't know how it's turned on, but some kind of stat CPU 1 or GPU stat 1, and it starts to gather for each frame. So it's gathered data 60 times per second and records it to, for example, CSV file, because CSV file is a table, and you can gather there as much statistics as you need. So you launch this performance tracker and play this level for, I don't know, like 10 minutes. Or usually they already created some kind of demo recorded, so gameplay itself. You know, sometimes in video games, for example in Cyberpunk, you see this benchmark of games, some kind of flights between characters, between city, between something that's happening. And later it tells you what was the performance like. The lowest FPS, the highest FPS, the average FPS, how much frame time for each frame differs, etc. 19 FPS, 18 FPS, wow.
Yeah, we dropped it.
Yeah, so
yeah, nice topic about these benchmarks. You know, I wanted to talk about it a little bit more because, you know, in Cyberpunk, for example, it is a common idea that this benchmark is not most overloaded scene. And there are so-called circle of death in Cyberpunk, somewhere in the center of the city where there is a lot of cars and characters and buildings. And in this scene, the actual FPS can drop more than in this benchmark.
Yeah.
So is it like a bad thing? I mean, does this benchmark should be the hardest part, or it's okay, or it's CD Projekt Red can do better and have a benchmark that really close this question? How do you think?
Cyberpunk is super complicated game. It's open world, and when it was developed for PS4, for example, they use technology that are used as a benchmark nowadays. So 6 years passed, and it still shows top of performance right now. I can say that this scene, Circle of Death, it takes 0.2% of time of player being there. So it's much more important. So all other game will be smooth performance, like 60 FPS. Yeah. But in this case, users may be a little bit patient and understand that it's not impossible to make everything work awesome. So what I need to do here? I need to maybe shut or it's okay. So yeah, you need to always find a compromise for this, because I know that.
Try your shield.
Yeah, something you shield, something. I don't know how it's thrown.
You can throw it.
Yes. I forgot.
Cool.
I played this game like months ago, maybe last time, and yes.
But by the way, in Doom, in this Doom Dark Ages, we have these huge scenes when you can fly on a dragon, and when you as a big monster titan, I can say.
Yes, it was amazing level.
I think to have this optimization, they just dropped the quality of everything. So they use assets that are much more low resolution than in the general game, right? It's a general tweak for optimization for nowadays games.
Absolutely agree with you, but it's not works like this. You don't use assets of lower resolution, for example. Nowadays, designers or artists, they draw everything in super high quality, like HK resolution textures are present in modern games, and that is because modern games have like 150 gigabytes of weight. But modern engines are super smart nowadays. They understand at first how far the object is, and if, for example, this stairs should be drawn in the highest resolution. For example, something that's in this furthest corner, this skull, it may be drawn in like 10 times lower resolution. That's really, and it will consume 10 times less video memory and everything. So this is the first thing. The next thing, to receive 60 FPS all the time, we have a setting that is called, it's called resolution scale. I have DLSS, no, so I need to remember. Resolution scale in mode, we have it static, so we may tell the game in what resolution to draw all the game. It is 2K turned on right now, but we can like put it in half and apply. Yes, and here, like in the right corner, we will see that 2K, but 50%. So now it's rendered like 50% from 2K. Do you see much difference? I think from YouTube, no, but I see that all pictures became smoother, like I'm playing on Xbox 360, you know. But as I mentioned, modern engines are very smart. And we can enable dynamic resolution scaling mode, and we can tell what target FPS I want to have. So, for example, I want to play in 120. So I play this, I enable this dynamic resolution, enter 120, and game will do everything to try to reach this FPS. So if you remember, when I played without this option, I had nearly 70 FPS. Now I have nearly 90, 100, something like this. This is super complicated thing because it requires the most power from all CPU cores that you have and from graphics card. But as we see on graphics of my graphic card power consumption, now it's 180 watts. We may understand that graphic card is working not on her top right now because the top consumption is the 250 watts. That may tell me that now the game can't draw 120 frames because of something else. What may this be? This may be video RAM, this may be CPU, or RAM itself. So as we see, my CPU has almost top frequency, like more than 5 gigahertz for each core and each thread. From this, we may think that this time my CPU stops my GPU from render more frames because it can't. It's not as fast as GPU to draw all these frames.
Can we go to this flying level to see how it works there?
Unfortunately not, because I'm only on the fourth level of this game.
You never fly in this game yet?
Yes, right now I did. I only played this level with Titan and it was amazing. Maybe we will play this level. So, what I wanted to say that for player, if you want to buy balanced PC for all the games, or you want to find appropriate CPU for your GPU, we have a portal on internet called gamegpu.com, if I'm not mistaken. I think we even may open it here right now. Game GPU. Yay, it will be on Russian right now, but I think I can switch language here. Yes, and we have this correspondence table, CPU with GPU. And for example, you have money to buy RTX like 4080, like I have here. So please, here you will see the list of CPUs that will open the potential of your GPU. So, for example, nowadays it's popular to buy at first PC without graphic card and later bought by a graphic card. And for example, you bought, I don't know, like used CPU with, I don't know, what may be popular, like a Core i5, okay, this 6600. Yeah, it's pretty old CPU, like almost 10 years ago. And we will see that these graphic cards are the top that this CPU may open, and the GPUs will be on top of their performance with this bunch of CPUs. So I always use this table when for example, friends ask me what to buy and where to save money. For example, they heard that nowadays 5090 RTX is the best, but they have maybe CPU with even DDR4 memory, and maybe that will be a bottleneck for your PC because you have powerful graphic card, powerful CPU, but this memory is not too fast to provide the so to combine all your PC in one.
Same question on YouTube. Your suggestion on GPU to buy
yes
today.
So just open this website and you will receive the best advice. Why this?
And maybe your opinion. If you will buy something tomorrow, you will go to the shop. What it will be?
You know, in in computers nowadays, it works the same as it's with cars and with flats. So the best time to buy PC was yesterday because we have all of this crisis all over the world and the crisis with not crisis, but you remember that all GPU cards are right now used by AI servers. All companies have bought all the RAM and the video cards for 5 years in future, if I'm not mistaken. So they already agreed to buy this amount of graphic cards that are not even developed right now. So what to buy today? It depends of your monitor, to be sure. As you remember,
monitor can be much cheaper than
yes.
GPU. So you can buy GPU first and then think about the monitor.
No, unfortunately not, because you need to understand in what resolution you.
What your target, right?
Yes, because nowadays we have all these LED monitors, OLED monitors, and times when we had, I don't even know how it's called in English, huge monitors with electric lamp, like fat monitors. SRT, right. Thanks a lot for the.
My dream. I'm dreaming of buying a good SRT monitor or TV.
Oh. I have 2 of them, and it was times when I bought a cable from HDMI to VGA to turn this old monitor to a modern PC. And I played Doom Eternal, previous Doom, on this old monitor in 100 Hz, and it was an amazing experience. I explain why. The feature of the CRT monitors, it doesn't matter what resolution you will enable in your game or on a desktop. You can enable 800 to 600 and it will be all on all the screen and all pixels will be real. What I mean by this, so like how this CRT works, they have some kind of tube that throws electrons to the glass, something like this. And when you tell it to throw 800 to 600, it will send exact amount of pixels. So you need to understand, if you enable 220 to 1280 resolutions or kind of AG, it will throw exact amount of pixels on a glass. So what resolution you will choose, this amount of pixels you will see. And that is why it doesn't matter. You can work in documents like in 1600 to 1200, and when you play video games, you may play like 800 to 600 resolution, and you will see best picture in any way. With LED monitors, it doesn't work like this, because here we have like physical pixels, like LEDs, so like small lamps, very very small lamps, like 8 millions of lamps. If we are talking about 4K monitor or TV. In this case, the best way to play will be to enable 4K resolution within the game or within the desktop, because in this case in this case, each pixel that your GPU generates will be exact lamp in your monitor. Exact. So pixel equals lamp. That is the best way.
We should, as a geeks, we should buy a 30 monitor. But for most of the guys, more common question: do you prefer OLED or IPS monitors?
I will answer this question, sure. Let me finish with the previous one.
Yeah, sure.
So you need to understand what will you play, on what screen you will play, and what you want to see. From my experience, you don't for single player games or even most multiplayer like Fortnite games, you don't need more than 60 FPS. The more important that your monitor will have 60 Hz, your game will be in 60 FPS, in smooth 60 FPS, as I mentioned in the beginning with this smooth graph. And you will have the resolution that your screen have. So that's enough.
But what about how it's called? I forget how it's called. When you have a high refresh monitor and you can play like in 50 FPS. We have this technology on PlayStation 5, I guess, when you have connection between. Yeah.
Yes, modern monitors and OLED TVs have this feature, so they will low frequency or a little bit higher. Exactly, it's called G-Sync in NVIDIA. So yeah, they are synced, and but you need to understand that this technology takes time, takes milliseconds to draw a frame, to synchronize these frames. And for example, if I'm not mistaken, when people do cyber sports, they disable this feature because it makes your game a little bit so how it's called, you have some kind of delay between your input and something that you see on the screen. This delay is milliseconds, but for cyber sports it may be important. So what I would like to advise here, you don't need to run after 4K gaming. 2K is enough. You may buy a monitor that has 32 inches, 2K resolution. If it's not very expensive, you may buy 220 Hz, but 60 is smooth. 60 is enough for almost every game. Yes, and I forgot your question. Sorry.
The second question was about OLED or IPS.
Yeah. If we're talking about video games, I would advise OLED. But we always have but in these technologies. If you dive deeper, what I received? Sorry, a new gun, impaler, weapon, high damage. So it's some kind of sniper rifle, I assume.
Spike impaler.
Yeah, headshots with zero bonus damage. Ooh, okay, let me try this a little bit. So, I would advise OLED, but you need, nowadays we have lots of different types of OLED. I can't remember exact name, but S OLED, P OLED, D OLED, something like this. And the problem is, we can dive deeper to this also, and we better to Google this, or you may Google this by yourself. Let me start playing. I can't explain fast and play this dynamic game. Right. I think we may even open. So difference between different OLED matrix. So the difference is how pixels are organized. You need to understand what is OLED. LED, they have like this small lamp pixel that contains from 4 small subpixels. For example, I want to find picture like this. It's small resolution again, but I will put it on. Yay! So the RGB technology, IPS screens, TFT screens, CRT monitors. Each pixel has 3 subpixels: red, blue, and green. From these 3 colors, you can enable any color like any from 16 million palette that we have. In OLED, we don't have this like I don't know, like this structured pixels. You see the difference. So each subpixel have different size. So blue, for example, has more. Come on. So it takes more place in pixel than other ones. It means that in OLED monitors that will have this structure, your picture will be more cool, more blue, more. So for some people it may be not convenient because you know that this blue light is more is harder for our eyes to see for a long time. And in our phones, for example, we have this mode. When you go to sleep, for example, you enable this night mode and it becomes more warmer, like in orange type or something like this. So
you personally, you vote for OLED, I guess, right?
I vote
from what you said.
Yes, I vote for OLED, but you need to understand that for video games, for work, I won't advise OLED with this structure because when you need to work with fonts, with text, with documents, you will see these sub-pixels, you will see some sharpness around each letter in your text, and your eyes will tire faster.
Faster.
Yes, that's it. But we have different OLED technology. You see this. Here we have 3 pixels, but most OLED right now have 4 sub-pixels. They have white to enable HDR and provide this 1000 of nits of brightness to, I don't know, it's also very bad for your eyes. Don't use this brightness like for a long time. But it's not just I choose OLED, I go to the shop, buy OLED monitor for $200. We have even of $300, and that's it. No, you won't be able to work on this monitor. But for video games, for dynamic scenes, OLED is amazing. And for movies, yes. So please,
thank you.
Dive deeper, because you see the pixels may be structured like in cross.
Yeah, but maybe the best suggestion just to try it with your own eyes, because I've heard sometimes for some people, even for some people, for some scenes, I heard like how these old monitors are called. That was before IPS, not VA, but no.
50.
Yeah. That these monitors, for some scenes, they look even good because of these not so sharp colors.
Yeah.
And if you play something like Max Payne, some moody game, maybe it will give you another atmosphere.
You know about TFT monitors? They have, but no, not today. Later they had one thing that they were faster. They were faster than APS.
Yep.
So this, how it's called, response time in milliseconds for TFT displays were faster. That's why first high-frequency monitors were not IPS, not OLED, they were TFT. But when you go left, right, up and down for your TFT monitor, you may see that your picture becomes darker or brighter. So they were great only when you straight before, so right to your eyes, to your face.
One more question from the audience. What is the strangest thing you have found that was affecting performance? Something you won't expect, right? Because it's pretty straightforward for DLSS, but
that of course. See, that I've tested. I've tested similar feature. It was an Unreal Engine about drawing faces and people's humans.
Mm-hmm.
You understand what I'm talking about?
Yeah.
Yeah, how to purchase. Yes, and you remember it was game, if I'm not mistaken, City Skylines, the most popular stuff about dropping performance, when you have huge city with roads, cars, skyscrapers, and even people working on near the road, and performance was like not terrible. It was unbelievably terrible because the game rendered teeth, so each tooth for each human within the video game. At the time when your camera was very up to the city, you didn't even could understand that it's what person it is. You just understand these are people. That's it. Like black dots, for example, like black lines are working there. But the game rendered even teeth in their mouth. So you don't need this. It's just about optimization. It should be disabled at all in this time when mouth is not open or you're not flying.
In this case, it's some kind of the bug in the engine, right?
Absolutely, it's a super critical issue with performance, and it should be fixed as soon as possible. But they imagine to release the game in this case.
But how is it possible? I mean, my question is, do we start performance testing as soon as we have something playable, as soon as developers deliver something, and how in this case some bugs like this can exist even, or I don't know, QAs are so overloaded that performance testing in the only for the end for the regression testing or something like that.
The thing is, you know how it works. You may test everything, but at the last time some changes appear and you don't have time for regression again. And in this case, you find a responsible person who will take all the all the heat to himself in case everything goes wrong, anything go wrong. And yes. Why it happens? Something was changed at the last time, and it was changed, and people may even didn't think that some change may affect this rendering situation. That's it. So you understand how it's working in applications and testing. You change something not related to the other part of application, but like a butterfly effect, it may break the whole application. Yes. So. You need to do at least smoke testing. You need to understand the main scenarios to play, so the main user scenarios, and include them in smoke testing, and do the smoke testing after it changed, especially before release. Developers might say that I've changed this small stuff, it won't affect anything, so just don't afraid push it to production. Unfortunately not. As testers, we should recheck on each platform because we have the same engine, but this engine works with different hardware. I'm stuck. I can't focus.
Have you tried to?
Yes.
Yeah.
Button.
Push. About these scenarios, just a day ago I saw a news from director of new Final Fantasy game, and he mentioned that he already completed the game for 40 times. And the previous Final Fantasy game took from 15 to 100 hours to complete. So I'm just amazed how it was possible to complete one such huge game for 40 times. And this is director of the game. He's not even a tester, so maybe testers did it much more times.
I want to say here that it was some kind of clickbait, because if it was the developer or the owner of the company of this game, of course he knew the shortcuts, some glitches. So I assumed that he did this some kind of fast track. So like how it's called, fast playing of each game with all glitches. I forgot this word. Okay, speedrun. Okay, so I think he used something like this, or he started from some location, or he skipped some scenario things. In some cases you may skip something in video game to see one of the endings, and other endings requires from you to finish all additional tasks. Let me return to performance a little bit. So I want to show how lowest graphics looks like. So I enabled handheld mode. I'm sorry. So let's think that we are playing on
Steam Deck, right?
Yes, on the Steam Deck, for example, the most popular handheld device that we have. So handheld. I like that more and more companies look at the Steam Deck as player on video game hardware market, and they optimize their products for this platform. So of course I disabled path tracing, ray tracing, if I'm not mistaken. In this game, I can't enable, and Doom: The Dark Ages was one of the first with Indiana Jones, if I'm not mistaken, who requires RTX graphic card not less than 2060, because all the light within this game is built on this technology. Before ray tracing, not all, but most of the light was baked, and some themes and shadows were calculated on the run. But in this game, all the light is calculated using this ray tracing, using this technology. I think that is the reason why I can't reach, for example, 200 FPS in this game, because I enabled handheld regime. Oh my god! It also can be in a short or something like this. So I enabled DLSS to auto performance, so it will be rendered in lower resolution, that's HD. The next thing I may do is to lower resolution this mode, but in this case our stream will be broken, because yesterday we tried how it works, and if you switch from 4K to Full HD or something like this, our stream is broken, because OBS takes the area of the screen and the screen changes, so it looks not great. So on my configuration, I may receive, with the lowest technology but not the lowest resolution, nearly 140 frames. It's great, it's super smooth, so I like this. And for me, I am the person who want to have more FPS than to have better graphics. On PlayStation 5 or on consoles, powerful consoles, you have several modes, performance mode, like performance mode and quality mode. In performance mode you have 60 FPS not looking at graphics, and in quality mode you will have 30 FPS. I forgot to throw the shield there. And in quality mode or graphic mode you will receive 30 FPS, but for example with ray tracing or with better light. So you need to choose in what way you want to play, and for me I prefer smoother gameplay than better picture. But it depends on the game, We have, for example, this genre that's called interactive movies, where you don't have dynamic scenes, and in this case maybe it's better. I'm doing something wrong.
About performance for interactive movies, I a fan of this example when Dark Picture game.
Of course.
Dark Picture, they released their game on Nintendo Switch, and
Really?
they released it in 24 FPS.
Movie experience.
Really movie experience on Nintendo Switch in potato mode in 24 FPS. I think it's nice.
Yeah, Nintendo Switch is a platform. It's all about compromises. It has. I don't know if we discussed this on previous streams, but it has a CPU, APU. It's called correctly. That on one chip you have CPU and GPU. That was developed in 2015, if I'm not mistaken, and it was developed by NVIDIA for the cars, for electric cars. Maybe for Tesla or something like this, but they can't agree the contract, and NVIDIA had this huge amount of chips, and they found NVIDIA who will buy this cheap APUs for their consoles. And using great optimization with great drivers that NVIDIA provided to Nintendo, NVIDIA Switch is a great console, but with lots of compromises. in this.
But I guess for the second Switch, it's the nowadays Switch with Switch 2 with DLSS. It's pretty capable of running modern games as well. Of course, but with I think the same graphics you have right now, but it will show that 30 FPS, and that will be okay for the handheld.
Yes, because if you play in a handheld mode, you have, for example, 7 inches screen with HD resolution. In this case, when you have 720p with DLSS, it renders, I don't know how much, 360.
3060, yeah, something like that.
And it's okay, it's fine. In this case, you want to have not more FPS, but you want to play without from battery without any cables for a couple of hours, at least a couple of hours. So in this case, you understand what you want.
Can power consumption be a case for the game testers in this case?
So,
I mean, for example, you test in a game for Steam Deck, or you're testing a game for some handheld PC like ROG, Li, and you're looking on the power consumption and can say to the developers, "Oh, we are going out of 30 watts, for example. It's not good."
That's right. Here, when we come to requirements again, for example, you receive requirement that your game don't need to use more than 10 watts per hour, and that's it. So do what you want, optimize how you want. I don't know, like sharp textures. Do anything, but no more than 10 watts per hour power consumption. So, yes, it's also again about optimization. You need, and also this. So I use MSI Afterburner for daily use, but in Unreal Engine, for example, we have all of the statistics implemented within the engine, and you can, as I told previously,
maybe a couple of words about the statistics. For whole this stream, we are watching the statistics on the left and on the right. Is it MSI Afterburner or is it built-in?
Yes. Give me a second. I'll finish this area. So to the left, thing that I may disable right now, and I'm enabling, it's MSI Afterburner, the most popular tool for gathering statistics for your daily basis, and if you want to understand how your PC is working. And it also shows you power consumption, as you may see. Like, let's go to that. For GPU right now I have 160 watts. For each core and each thread of CPU I also have this watts, and here I have CPU like 70 watts right now in common for all cores and threads. The same you may enable on a Steam Deck or on any handheld that has Windows-based handheld. In Steam Deck, it's called in some other way. It's also built in the Steam OS, and you may manually low consumption on operation system level, like no more than 5 watts, and you will play like Hollow Knight. Or some indie game that has 2D graphics and it doesn't consume graphic card at all. So you may see this consumption. I don't remember if MSI Afterburner allows it, but we have tools. In MSI Afterburner, we have Riva Tuner Statistics Server. Here it is. In this tool, I can set frame rate limit. For example, I don't want to see more than 10 FPS. For example, let's show how it works. I enable 10 FPS here, open the game, and you see that it locked on 10 FPS. It doesn't matter how powerful PC I have, I will receive 10 FPS. And it will be, of course, terrible, it's not possible to play. But I use this tool when I want to receive 60 smooth FPS, and when I enable vertical synchronization to receive the most smooth gameplay. refresh rate 60, vertical sync, triple buffering. So if I'm not mistaken, it's it's great thing. So that was I was talking about. 60 FPS, each frame not tiered, and we have this flat graph. So this is the best thing when you can play. If you have monitor 120 Hz, you just lock your frame rate to 120. You enable all the graphics like dynamic scaling, for example, to receive this 120. And in this case, you see that my graphic card works only for 100 watts. When on top of its performance, it will work on 250. So twice and a half more power consumption. So for stationary PC, it's not important, but for handheld devices, it's one of the most important things. I wish
This monitoring on the right.
The monitoring on the right.
It's from the engine, right? From the game
Absolutely.
itself.
As you may know, Doom is built. Each Doom game was built on its own engine, called Ep6. So this is the 8th version of Ep6, and Ep6 is one of the most optimized engines like all the time, because not much games have this statistics built into video game. We can see its frame generation is turned on, HDR or not, RTX or not. Maybe I will turn here. So RTX, it's always on in this game. Vertical sync, resolution, what processor do I have, what GPU. Even we see the settings of the game on what level. So look at shadows. It's like 0, not disabled, but the lowest. And when it was on top of the settings, it was UH like UN like Ultra Nightmare. So the most powerful, the most hard configuration. So how much RAM, video RAM is used, how much is free, what driver, NVIDIA driver I have. So for some kind of even investigation or understanding what your game is looks like and how it works, is the most powerful thing. I know that in this engine, in this game, you can, within the console, enable some statistics gathering to a file, TXT or CSV, it doesn't important. And if you are working with the engine, you have some scripts or tools. So performance team, optimization teams, they always have tools that will rebuild your CSV file to some beautiful graphics, and you will see in what frame, in what second, why there was lower FPS, and what happens to the scene. What takes performance. About what we are talking about. We're talking about performance. About draw the picture. We have 3D environment, or 3-dimensional environment. So each object here is a 3-dimensional model. Each model it consists of triangles that called polygons. Triangles because from triangles you can it's the not easiest, the most simple geometric figure from what you can build any object. You can't build any object from lines, from squares. It needed more power because you have in square you have 4 dots to calculate. In triangle you have only 3, and from triangles you can build any object. The more triangles you need to draw, the more powerful graphic card you need. And in engines, you can even enable statistics how much polygons is drawn within the frame. There are not millions, but billions of polygons, if you may understand. And this is also very important metric to understand how much polygons is top of your computer to calculate. If something
handle, yeah.
Yes, and the more on these polygons later you need to put textures. Textures also consume video RAM, so it's connected everywhere. And if you see something happens with your performance in the specific scene, you need to understand what differs this thing from other ones where performance is okay.
Thank you for your answer. We have only 1 minute left and we have one more question, so let it be a fast answer. Have you ever tested Counter-Strike 2, Pavel?
Unfortunately not. I didn't even play Counter-Strike 2. The last Counter-Strike I played was Counter-Strike
1.6. For me, it was 1.6.
1.6. I played it not so long ago, but Source was the last Counter-Strike title that I played. But I know that Counter-Strike 2 is used by different bloggers and persons who
Like a benchmark, right?
Like a benchmark, that they always disable all the graphic features, disable vertical synchronization, and to see
the best.
yeah,
What
to see
is the
how
best FPS
hundreds
you can
of
get?
FPS you will receive. Yeah, as I mentioned, Cybersport, it has different requirements.
Mm-hmm.
So you don't need ray tracing in Counter-Strike or any other competition game because it consumes more than a half of your power operating cards. Just imagine, more than a half. Why?
Thank you. Thank you, Pavel. Thank you for your answers. Thank you for that stream. I think this talk about performance testing in video games are quite insightful. And, at some point, I think it's quite fun exercise each gamer can do, to play with all this. The first step, just enable all these statistics, play with your settings, play with your games, travel around and just think, about how you can test it. That's pretty insightful.
Yes.
Yeah. Thank you very much for that stream. Thank you everyone who was with us this morning. I hope this was insightful and fun for you. Please, you can add any comments. We will be glad to answer them even after the stream. So thank you very much and have a great day. Have a great weekend.
Thanks a lot for your questions, for your patience, and for your presence here. Presence here. So if you want to see something like this or continue to talk about performance because I didn't show the frame generation, for example, and maybe you googled something that you don't understand how it works, it would be a pleasure to show it to you, or maybe to test another game. For example, Alan Wake 2 is one of the top games that consumes all the all the things from your PC. So we can test it also. It also has path tracing and all these shadows and super realistic faces and animation. And I like this game super very much. So maybe Alan Wake 2 is the next title that we will play, if you wish so. Yes, thanks again, everyone. Have a great Friday and
have a great Friday.
Bye bye.
Bye.
Oh, here. Come on, just tell me when we are offline because I'm continuing playing. Amazing game, better than 2 previous ones. Not much people think like this, but I'm fond of Doom Like